Hi, welcome to the section, Making 3D Visualizations. In the previous section we explored more about plots and customizations. In this section we'll learn how to create 3D bars and 3D histograms. We'll also see how to animate in Matplotlib with OpenG. Now we move on to the first video of this section that deals with creating 3D bars. In this video we'll first specify the back end and generate random data for 4 years of sale. We then specify Z values to be the same for the 3D axis, and lastly we associate each Z order collection of XS, YS pairs. In this video we're going to explore more about Matplotlib and learn how to create 3D bars. Let's see how to do it. For this section we'll use the Nthought Python distribution, i.e. EPD. You can download this from the official website www.nthought.com. Click on the Products tab. Select EPD, which you can find at the bottom of the Products tab, and click on Get Nthought Canopy button, located at the bottom of this page. As you click here, you then need to click on Package Manager to download a few essential packages which we are going to use in the coming videos. So you need to install Basemap and May AVI. Once you have downloaded these packages, move on to your editor. Let's now get ready to create 3D bars. Although Matplotlib is mainly focused on plotting and mainly in 2 dimensions, there are different extensions that enable us to plot over geographical maps to integrate more with Excel and plot in 3D. These extensions are called toolkits in the Matplotlib world. A toolkit is a collection of specific functions focused on one topic, such as plotting in 3D. Popular toolkits are Basemap, GTK Tools, Excel Tools, NatGrid, AxisGrid and Matplot3D. Here we first explore more about Matplot3D. Toolkit mpl_toolkits.matplot3d provides some basic 3D plotting. Plots supported are scatter, surf, line and mesh plots. Although this is not the best 3D plotting library, it comes with Matplotlib and we are already familiar with the interface. So basically we still need to create a figure and add the desired axes to it. The difference is that we are now specifying a 3D projection for the figure and the axes we are adding are axes 3D. Now you can use almost the same functions for plotting. Of course the difference is the argument. For we now have 3 axes which we need to provide data for. For example, the mpl toolkits.matplot3d.axis3d.plot function specifies the XS, YS, ZS and ZDIR arguments. All others are transferred directly to matplotlib.axis.axis.plot. Let's understand these specific arguments. XS, YS. These are the coordinates for the X and Y axis. ZS. This is the value for the Z axis. There can be one value for all the points or one for each point. ZDIR. This chooses what the Z axis dimension will be, which is usually ZS, but can also be XS or YS. An interesting thing to note here is, there is a method rotate_axis in the mpl toolkits.matplot3d.art3d module that contains 3D artist code and functions to convert 3D artists into 3D, which can be added to axis 3D to reorder coordinates so that the axes are rotated with ZDIR along. The default value is Z. Prepending the axis with a hyphen does the inverse transform. So ZDIR can be X, hyphen X, Y, hyphen Y, Z, or hyphen Z. As you can see, this is the code to demonstrate the concept explained here. Let's now dive into the working of this code. Here we had to do the same prep work as in the 2D world. The difference here is that we needed to specify what kind of backend. Then we generate random data for supposedly 4 years of sale, i.e. 2011 to 2014. Also, we needed to specify Z values to be the same for the 3D axis. We picked the color randomly from the color map set and then we associated each Z order collection of XS-YS pairs that would be used to render the bar series. Let's now run this code. This code produces the figure which you see on your screen now. Let's now dive into some additional information. The other plot from 2D Matplotlib is available here. For example, scatter function, which has a similar interface to the plot function, but with increased size of the point marker. We're also familiar with contour, contour F and bar. New types that are available only in 3D are wireframe, surface, and tri-surface plots. For example, this code example plots a tri-surface plot of a popular Pringles function, or more mathematically, a hyperbolic paraboloid. Let's check the output of this code too. So this is the 3D tri-surface plot, which you see here. Awesome! In this video we explored mplot3D and saw how to create 3D bars. In the next video, we'll be creating 3D histograms.